Hello, today we're going to be looking at equivalent expressions. So, equivalent means equal or the same value. Our opening exercise is a situation. Let's consider that we have an envelope, and this envelope is going to contain a number of triangles and a number of quadrilaterals. So we don't know how many triangles or how many quadrilaterals are inside of our envelope. So we're going to let T represent the number of triangles. And we're going to let Q represent the number of quadrilaterals. We're going to write an expression using T and Q that represents the total number of sides in our envelope. And we're going to explain what the terms and the expression represent. So, triangles have 3 sides. For the total number of sides, it will be 3 times the number of triangles, plus quadrilaterals have 4 sides. These are both examples of quadrilaterals. Closed for Q. This is one term, this is another. Together, these terms make an expression. This first term, we have 3 sides times the number of triangles, because each triangle has 3 sides. Here we have 4 sides times the number of quadrilaterals, because each quadrilateral has 4 sides. So this is one term, and this is another. And it says, explain what the terms in your expression represent. So this term is going to be the number of sides for the triangles. And this is going to represent the number of sides for the quadrilaterals. Now remember the situation. I don't know how many triangles and quadrilaterals are in my envelope. The whole expression together represents the total number of sides in my envelope. So just for argument's sake, let's say that I open this envelope up and there are 2 triangles in my envelope and there are 6 quadrilaterals. So to find the total number of sides for this given situation, I'll take my expression and I would replace T with 2 because I have 2 triangles. Each triangle still has 3 sides. And then each quadrilateral has 4 sides. So 6 total sides for my 2 triangles. And for my quadrilaterals, if there were 6 of them, and each one has 4 sides, that's a total of 24. So add that together, and that'll be 30 total sides if this is what's in my envelope. So now we're going to look at some more examples. We're going to use the any order, any grouping property with addition. So any order is actually the commutative property. and any grouping is the associative property. I'm not sure why this material uses these wordings, but we're going to use the true math words. Okay, so we're supposed to rewrite 5x plus 3 and 5x minus 3x by combining like terms. What are the new expressions equivalent to? So you're going to rewrite these by combining like terms. Write the original expression and expand each term using addition. So, we'll start here with this one. I've got 5x plus 3x. 5x's. Remember, multiplication is repeated addition. 1, 2, 3, 4, 5 x's plus 3 x's. 1, 2, 3 x's. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8 x's. Now for this one, I would have 5 x's minus 3 x's. 1, 2, 3, 4, 5 x's. And then I would remove 3 x's, leaving me with 2 x's. For the next section, we are to find the sum, which is the answer to an addition problem, of 2x plus 1 and 5x. So we're going to use some of our properties as we work through this. I'm going to put the 2x and 5x together. So in order to do that, I'm going to use a variety of steps. First, I'm going to switch the order of the 1 and the 5x, and that's using the commutative property. Then I'm going to group these together. So that's the associative property. Let me separate this out. And I'm just copying this over because I ran out of room there. So if I have 2 x's and 5 x's, that's a total of 7 x's plus 1. This number that tells me how many of the x's I have, that is called a coefficient. Sometimes we think of it as the number being multiplied by the variable, but it tells us how many of the variable we have. So 7x plus 1 is my equivalent expression. It's equal to this. This and this represent the same amount. They look different, but they represent the same amount. They're in different forms. This is more expanded and this is more standard. This is standard form. So let's move on to the next question. Find the sum, so again an answer to an addition problem, of negative 3a plus 2 and 5a minus 3. So I think I'll write it over here to have a little more room. Negative 3a plus 2 and 5a minus 3. So, first thing I want to do is move all of my a terms together. I'm going to group those together. Then we'll move all of my constants. That's what we call just numbers. We're going to put those all together. And then we'll combine our terms. So we're going to use some of our properties. Since I only have addition and subtraction here, I can go ahead and remove those parentheses. I'm going to switch the places of these two terms. Okay, and then I have to bring that one down. So what I did here is I used the commutative property to rearrange this so all of the like terms are together. Like terms are terms that have the same variable. So here I've got negative 3a and 5a. So if I wanted to expand it, I could go 5a's, 2, 3, and then take away 3 of those. 1, 2, 3. Leave me with 2a's. 5 minus 3 is 2. And then these two terms are like each other. So I have 2 minus 3. I could think of that as 2 minus 3 is 2 plus negative 3, if I wanted to. Regardless, the answer is negative 1. I might write that as 2a plus negative 1. These are equal to each other. They're also equal to the terms that we started with, and they're also equal to this line. So here we actually have 4 different equivalent expressions. 1, 2, 3, 4. This would be standard form, but it's important to understand they're all equal to each other. Now we have product. Find the product, which is the answer to a multiplication problem, of 2x and 3. Now, we could use the little multiplication dot. We don't have to. We wouldn't want to use the x for multiplication inside of this, because then it would look like you had 2x, x, 3. That could look confusing. So what if somebody wrote it this way? That looks really confusing. So we're not going to write it that way. We're going to use the multiplication dot or just the parentheses. So 2x times 3. 3 groups of 2x. I'm going to actually write that down. 3 groups of 2x. Keeping in mind that multiplication is repeated addition. 2x plus 2x plus 2x. 2 x's and 2 x's and 2 x's gives me 6 x's. Now also, 2 times 3 is 6. So again, we have many different equivalent expressions. This is an expression, this is an expression, this is an expression. These are all equal to each other. This version here, 6x, is standard form. Some people might refer to it as simplified. Standard form is the correct math term. Okay, so now we're going to get a little more complex as we move through this page. We have 3 groups of 2x. We just looked at that. We said that means 3 groups of 2x, which would be 6 x's. Okay, and I'm going to draw a box around our final answer that's in standard form. Okay, 5 groups of 4y. 4, 8, 12, 16, 20. Also remember that 5 times 4 is 20. At any rate, standard form, 20y. Okay, here we have 4 times 2 times z. Well, 4 times 2 is 8 times z. 8 times z is 8z. Okay. Next section. 3 groups of 2x, which we've done a couple times now. We know that's 6x. 5 groups of 4y. Now, at this point, some people might try to put those together. You cannot put these together because they have different variables. Sometimes, to help me understand if I could put it together or not, I'll say, okay, so x is an x-ray. 6 x-rays plus 20 yo-yos. Can I put that together and say that's 26 somethings? No. It's 6 x's and 20 y's. So this is standard form. These are not like terms because they do not have the same variable. Okay. Again, our 3 groups of 2x, which is 6x. 5 groups of 4y, which is 20y. And then 4 times 2 times z is 8z. And this is standard form. All of the like terms have been collected. It's a little messy, but that's okay. final question on this page. Alexander says that 3x plus 4 is equivalent to 3 times 4 plus x times y because of any order, any grouping. Is he correct or not? Why or why not? So 3x, I'm going to write it here a little bit. 3x plus 4y. That would be x plus x plus x plus 4y's. Okay. This, 3 times 4 is 12 plus x times y. When I look at these are not equal to each other. And the expanded form shows why. It shows that this one would not end up with 3 x's. This is 1 x. This is 1 y instead of